Okay, so what am I going to talk about today? I'm talking about Docker and more specifically Docker images when we use them in production. I haven't done this yet. We really only use it in development, but we are on the verge of deploying our first big deployment of the Docker into production. It's quite big. It's 11 separate container images, which is used by 34 containers in total. So there's quite a lot there. It's all controlled by Kubernetes. So something weird to my sound. Hopefully it's gone. Okay, cool. Right, so images. How do we define a Docker image? We know that they contain our application and they should contain all of the dependencies that application needs in order to run it. This is what we do regularly on a day-to-day basis. But Docker actually defines it as an image is an ordered collection of root file system changes and the corresponding execution parameters for use within a container runtime. Which sounds horrible, but essentially what it is it's a set of changes from a base image that are just layered on top of each other, and then a final way of executing that image or a container that image runs, that image. So it's pretty simple, really. And a really, really simple example of that is this, where essentially we are getting a Debian base image. We copy on a file. In this case, it's an imaginary binary called hello, and that just gets copied onto into the root of your image. And then there's an execution parameter, which is telling it just to run that binary file. So that's just a two-layer image with a third instruction at the end. It's really simple. So what's the problem with that? And I guess there isn't really a problem with that, other than the fact that our imaginary hello binary doesn't need the entire contents of that base image in order to run itself. It doesn't have any dependencies. It doesn't need it. It doesn't require anything really. So we're including a whole load of stuff potentially in a production image that isn't required. And doing that opens yourself up to any vulnerabilities or bugs that are in those other files that you don't need. So just taking a step back then to development versus production images. In development, we need everything. So we want all your development libraries that are required in order to build our gems or our node modules. You need all the tools that you need to in order to build those things like GCC and other compilers. You need the ability to write and run your test suites because that's important. Not necessarily you don't need that in production, but you do need it in development. And you also need some debugging tools as well. And there may well be a whole load of other stuff that you have that you don't necessarily need in production, but it helps you with your development. So Docker is great for that because you can bundle it all up to a single image and you've got yourself something perfect for your software engineers to work with. But production is different. We don't need all of that. So you want to really just have what your application needs, just those libraries and tools that it needs in order to run, and nothing else. So most of you would have probably seen or used the slim versions of your Docker base images. So here we've got Node 14. There's a Node 14 slim version. Ruby 2.7, there's a Ruby 2.7 slim version. So these are basically the same as the slim version is basically the same as the original versions. The only difference is they don't contain a lot of the build tools and the dependent libraries that come with the other versions. They're generally all based off of a Debian base image as well. Other alternatives are like distros like Alpine. Alpine's really small. it's not as well supported as Debian images are. There's also, it's based on slightly different technology as well. So there's other sort of issues that can arise from using Alpine, compatibility issues and things like that. So I kind of, although I looked at them originally, I kind of steer clear of them just because they can be, a little bit scary. Just as an example of the physical size of those images, the Node 14 is 942 megabytes compared to the Slim version, which is 165. So, there's a big difference between these. You wouldn't be able to, you could use your Node Slim, for example, to do your development, but you're missing a whole load of stuff that you're just going to have to add anyway. So there's really not a lot of point in using it. But in production, that works, and it's not bad. So it doesn't quite go far enough. And the reason why it doesn't go quite far enough is because of the vulnerabilities that will exist in those images. They might be the most recent and up to date, but they will probably still have some issues. So there's a number of different vulnerability scanners that you can get to look at your image and see what issues there are. I've been using one called Trivy, and what it does is it just scans your image and will highlight any CVE issues that there are within the files contained inside of that image. It'll also scan your gem file.lock file. It'll look at your package.lock files. It'll look at yarn.lock files. It'll look at all of those and pick out any vulnerabilities in all of those things. It can also be integrated within your CI pipeline, so you can use it to verify an image is good enough to go into production through your CI. So as an example of this, and it isn't the best example, but I think it kind of shows. So both of those Node and Ruby images are based on the BuildPet Depth Buster image. And this is what's Trivy's kind of summary of what issues there are within that particular base image. So, the lows and mediums maybe aren't so worrying, but, you've got 115 high issues and 12 critical issues within that image, which is not great. If we take a look at one of our Stonehaven images, this is basically built off of that original image, and you can see it's added a few mediums and a few lows, so it's got slightly more, but it's not crazy. Compare that with the Slim, and by the sheer fact that it has less files on it, it's quite a bit better. There's only 26 high, so that's quite a dramatic change. But there's still 5 critical issues contained within that image, which is maybe too much. So the other output that you get from Trivy is this sort of thing. So this shows you what issues there are. It gives you the CVE numbers, the severity level. So this is from that BuildPet Debs image of Debian. You can see these are the high issues, or some of the high issues that are in there. Now, things like Bash, do you need Bash when you're running your application? You don't ever necessarily use it. Pretty sure you don't necessarily use Perl in it. So, unless your app, it runs Perl, why is it there? Do you actually need it? So what if you could start with nothing? That would be the easiest thing to do, right? Just start with a completely blank sheet and just add the bits you need. And that's fine to an extent. So we could do this with our previous example. And we have Scratch, which is our kind of pseudo image, which doesn't actually have anything in at all. It's just literally a way of saying start with nothing at all. We can copy our binary on again and have our same execution parameter to run that executable. Now, this is all fine, assuming that your binary needs nothing else to run. It's literally just that. That's all it requires. There's no dependencies at all. Now, that's not the case at all with most of the apps that we create, you know, all Ruby apps and Node apps require something a little bit more. So what you want to do is then have like a minimal based system as possible. And Google have been doing this for years now, and they have what they call distroless based images. So Distroless Docker is a set of base images that are like a minimal Linux glibc based system. It doesn't have any shells. It doesn't have package managers. It literally doesn't have anything that you'd normally expect to see in a Linux distribution. Or so then you think, well, okay, that's great, but how am I supposed to use that? Because I need to install packages and things like that. So obviously you need to do that. So just as an example now of the differences between the two, this is a scan of a base Debian image. This is the one if you just pull down Debian 10.03. This is what it'll be. It'll have 3 critical issues in it. Compare that to the distroless version, it's a lot less. No critical issues at all, which is really what you want to see. Still has 1 high, but that is actually glibc, which you can't do a lot about that at the moment until that gets patched. Also, it's worth noting that the size of that top Debian image is 114 megs, which is pretty small, but it's still fairly chunky. Whereas that distroless version is only 19 megabytes, so it's a lot smaller. So now we have to install our application and dependencies. And to do that, we use multi-stage builds. I don't know how many people are using multi-stage builds at the moment or have used them, but I'll just run through effectively what they are. So it's a really handy way of keeping your image sizes to a minimum or excluding certain things from your final image by doing some of the hefty work in a first stage and then copying the bits that you need out of that first stage into your final image. It's not really that handy in development because, as I said before, you kind of want everything in your development images. It's quite important that you have all that stuff because otherwise you'll just run into problems of missing libraries and stuff like that the next time you try and compile a gem or something like that. But for distroless, this works really well because it means that you can create your do everything you need for your final production image, just copying the bits that you want at the end. So this is an example. This actually comes from the distroless repository. So we start off with a standard node base image. So this one will be based on that Debian image. The as build env bit on the end is just naming this stage so that we can reference it later on in the builds. We add just the contents of that directory that we're in to the /app directory, set that as a working directory, and then run npm clean install just to install all the node modules that are required. So at this point, that is potentially a runnable application, but obviously that's got everything on it that comes with that node-based image. So the next step would be then to have our second step within that build, and that is to use the Node.js distroless it-based image. Now, they have a number of these. They don't have a Ruby one, but they have a Node one. There's like a Java one, a Go one, and a few others. They're not at the moment. They say they're not necessarily used for production, but they're not. Essentially, all that's really the difference is it's the same as the other base images for distroless. It just has nodes put on it as well. So it's kind of missed out a step that you don't necessarily need to do. So using that, you can then reference that build env stage from before, and we're just copying the entire contents of /app to /app on our new stage. Obviously, that /app from the build-m stage now includes all the node modules that are required for your application as defined by your package.json. We can set a working directory and give it an execution parameter. So that would give us sort of as clean as we can probably get a node image that will run that hello.js file. Pretty simple. Ruby is a little bit more complicated. It's a bit more complicated because it has quite a few more dependencies. Node essentially is contained within a single directory inside of an application. You can just copy that entire directory over, and that's it. Ruby links to a lot of different libraries inside of your OS, so it takes a bit more effort. So I'm just going to quickly share my screen to this one. Okay, so this is a Docker file that I've just made for a Rails application. It's a multi-stage build, so I've pulling down the Ruby 2.7 base image, and I'm just giving it a name of hello build. There's a few things here you might well have seen before in any Rails application. So I'm adding the yarn sources, app sources, and then I'm doing an install of Node.js and Yarn because we need both of those to run this Rails application. Just copying on the gem file and gemfile.lock into an app directory, setting that working directory again, and doing a bundle install. That's all fairly standard stuff. We've seen it all before. Next, the multi-stage part of this is to base this step on the base Debian 10 image. So that is, there's a static version of this as well, which is a bit smaller, but this has basically not a lot on it. It's that small image. It's pretty tiny. We copy on our app. We have to set a few environment variables. So I'm adding user local bin, bundle bin to the path, and I'm setting a gem home environment variable as well, just so that it knows where to look for my gems. And then we're just copying from that hello build stage the various parts of that we need. So we need all the bundled gems that we've just done. And then this is where Ruby gets a bit complicated because it requires some files from various different places around the OS. We set the working directory again, expose a port, and finally we run the application. Now that should be enough to run the Rails app. This doesn't run. It doesn't run because it needs Webpacker as well, and Webpacker goes a bit funny. So it needed a little bit more work, but trust me, it does work. So that's the Docker file. Just to sort of compare the image sizes of those. The one at the top here is our final image. That's 724 megs, and the one below is the actual build step, hello build step, which is quite considerably bigger because it's got all of those dependencies in it that we need it to build the gems and the node modules. So part of how you work out what you need in here is, well, firstly, it's a bit of trial and error. Firstly, you have to try and run the application. If it works, then you can, it's great. But if it doesn't work, there'll probably be something that's missing, and you have to go looking for those. I use a program called Dive. What Dive does, it inspects your Docker images and allows you to view each of the layers and work out where things are and where you need to copy stuff. So on the left-hand side here is each of these is a layer or a command that's been run to build it up slowly. And then on the right-hand side, these are the files that exist within that image now. So it's a fairly standard OS looking image. And one of the things we can do is just show the things that have changed. So I've turned off the unmodified files. So these first few steps are actually the steps from the Ruby image. So they're doing things like installing Ruby, installing the dependencies. It's, you know, installing Git and Curicle and all sorts of other dependencies that you don't necessarily need. This is our steady run, so that's fine. We're happy. We can install all of that. That's not a problem. Lots of stuff getting added, and let me just reopen up that. You can see as we go through the layers that you know, these files are all being added on. And we get down to the first part of our stage of the images. So all of those ones above were from the base image. So this is now our part from R. So this, the first thing we do was to add the yarn source to our image. Then we do a yarn install and Node.js install. So that's installing everything that we require for those. And that's us copying the gem files on, and then a bundle install. And you can see like that, you know, where like the size comes from. So, you know, here we have like 281 megs is just doing that bundle install. And there's quite a bit of stuff in here. You know, there's a whole load of cache that we don't necessarily need. We're only really interested in the user local bundle directory because that's the only bit that actually has the stuff that we want. You know, all this stuff in root is not needed. It's just cache. It's just not required. So we can exclude all of that. So if I move on to our actual final image, so this is the one that's based off of, so this is the second stage of our build. Again, we can step through the images. So the steps, the layers. So the first layer is the static build of Distroless Debian. Bazel is Google's open source image building tool. I've not actually tried it out, but that's what they base all of their, that's how they build all their images. They don't necessarily use Docker files. And then we get into the bits there. This is where we're copying stuff on. So if I just, again, if I just show the stuff that's changed, this is, we copied on our application. So that's our Rouse app. We copy on our bundles. So there we go. We can just see that that's just all the bundle stuff, nothing else. And then, you know, as we go down, that's copying on that lib, x86, 64, Linux, GNU, and so forth and so forth. So that you can see what we're adding. So hopefully that kind of shows like what we're doing there. I'm just going to quickly show you also the trivia results of that. So if we took, if we just run trivia on the build stage, we can get the results from that. So this is just showing the high and critical, but you can see there's quite a lot here. There's a lot of stuff that's been that's in that base image. There's loads. In fact, it's the same number as our Debian 4. So there's loads there, and there's things in here we don't necessarily need, like Bash. There's Python on here. There's various bits and pieces that really, why are they there? I think there's tar at the end, and then tar has a Perl. Why have we got Perl on there? Yeah, it's tar has a critical issue. Why do we need tar? We don't. Unless your application specifically needs it. You can also see here that it's looked through the gem file.lock. It's also looked through the gem file.locks inside of the gems themselves. And you can see that, you know, there are issues with some of these gems, which, you know, technically there's not much you can do about those, because unless those get fixed or there's newer versions of, say, Webpacker that fixes that, then you can't do much there. If we then compare that with the final image, we can see that there's a lot less. In fact, there's only one high issue now, which is this libc6, which we can't really get rid of because that's part of glib, and that's required for the OS to run. So let me just switch back to presentation. Okay. So where was I? Right. Yeah. So anyway, hopefully that kind of shows you that using those base images really help us reduce the amount of vulnerabilities that are in the final production image. So there's other things to think about. You should always avoid using privileged users to run your application. The Distroless images come with a set of users pre-created, a no root and a no body, which you can use, and the corresponding groups. So that avoids that issue. It's kind of a fairly obvious one, and it's the one that we obviously use with our repositories, is to keep sensitive information out of that final build. So say as we do with Stonehaven, we have to download some private gems, and that requires SSH keys in order to do that. So we have to put those SSH keys into the first stage of the build in order to be able to do the bundle. But we don't want those SSH keys in the final build, because that's going to be potentially releasing that private key. So we can do that in a multi-stage build, and then it won't be there in the final build. It's still not ideal doing it that way, but until there's a better way of doing that in Docker, that's the way we have to do it. Debugging takes a bit more time, because obviously there is no shell to debug with. So you need to, and if you need to be able to get onto that container to be able to see it, dive is great, but it doesn't give you much control. There are debug versions of the Distroless images though, so you can just change the tag to debug, and that gives you the ability to change the entry point to SH, and then you'll be able to get on and do a little digging around. You still don't have all the other tools that you might need in order to debug, but it helps you at least try and debug what's going on when your image is not building correctly or not running when you expect it to. And the other thing is to use the Docker ignore file, because you don't need half the stuff potentially. Like, you don't need all the spec directory, say with a RAS app, to run it in production. It doesn't need to be there. You can reduce the size of your image using that. But that does have its own problems, because you can only have one Docker ignore file, and you don't want a different Docker ignore file. You'll need a different Docker ignore file for development, because you don't want to exclude your spec directory, for example. And at the moment, there's no way of defining a Docker ignore file on the command line when you do your build. So you have to copy things around and do some weird stuff, so which is a little bit more painful. But that's largely it. We're running out of time already. So yeah, I think I've just scratched the surface, really. There's a hell of a lot more you can do with this, but thank you for listening. And are there any questions?
Yeah, I just had a question about the multi-stage builds and image layer caching. So obviously, normally Docker will cache each layer, and then if you change one in the middle, that'll cascade down and invalidate all the ones below that. I assume that works the same when you've got multiple stages. So say you've got 3 stages and change something in the second stage, that will still cascade down and invalidate the entire third stage cache.
Yeah, so each of those stages gets is essentially, it creates its own image.
Yeah.
Every time. So so those images, I don't think it's a good question. I haven't actually tested to see whether or not if you changed it in stage 1, say stage 2, it would affect stage 3.
You assume because it's potentially copying stuff in, then
yeah,
you would have to.
Yeah, if it's using that previous stage, in your next, then it would cause a problem. But when you do if you do a Docker images on your machine, you'll see a whole load of images without any name, and they are all of those cached layers at those cached stages.
Yeah.
Cool.
Nick, go ahead.
It's only a quick one, Josh. Cheers for this, by the way. It's really interesting. What was I going to ask now? Oh, size. So I realised, this is amazing that you can chop something down this small. Is there a reason that you are needing to chop it down quite so small, like leaving out bash and stuff like that? Is there some kind of limitation?
Well, it's not necessarily the size of the image that is the reason for doing this. The reducing the size of the image is beneficial from a point of view of the loading of that image takes less time, and if you're storing these images in the cloud, say, then you're reducing your cost by having smaller images stored there. But really, with Bash, the thing is actually it's more about removing that because it has vulnerabilities. You don't need Bash in order to run the application. It isn't required. So why have it there? You don't need it. You just take it out. That's the whole point. So it's not about necessarily the physical size of the image so much. It's more about removing anything that isn't needed and having just the bare minimum.
It sounds like you might have to, at some point, weigh up the positives of doing that, and then the negatives of not being able to investigate any problems.
Yeah, and that is the only real negative, is that inability to then go on to that and work out what's wrong. But hopefully, by the time you're in production, any issues that you're seeing are coming through in your log files, rather than actual physical problems with the what's on that image.
I guess the flip side is that hopefully your platform you're deploying to should also give you the tools that you need to do some of that without it. Like in Google Cloud, you can use StatDriver to add debugging and stuff like that. So
absolutely.
That's necessary.
Well, hopefully your log files will tell you what's going on, what's missing, or what's not there. If you try and run Rails before adding some of those, copying in some of those directories that I did in the doc file, it'll say, this particular library is missing or that particular library is missing. So,
cheers. That was good. I look forward to hearing to part 2 where we actually deploying it, because that's definitely the magic for me. I've never actually pushed a Docker image to us somewhere where it's actually run. So.
Yeah, I'll do something on Kubernetes, because then Kubernetes is it's a massive topic actually, but I can certainly think that it's quite interesting to see how that's done and the way that Kubernetes works. Yeah. Josh, did you have a question?
Yeah, just had a quick one. I'm guessing you've kind of had an idea of what you were talking a bit about development and production, and you didn't need to necessarily say it now, but it would be nice to get an idea of what it would look like on a project. Is it one Docker file, or is it 2, or kind of what that looks like?
Yeah, so I've actually got I now have 3 in some of the apps in Stonehaven. One is for production. So there's one Docker file that is literally the production version, which cuts down everything. There's a development version, which is the non-cut down version. And I've actually created a test version as well for running specs in CI. And the reason for doing that was actually more to do with limitations with the GitHub Actions matrix for running multiple versions of Ruby against multiple versions of Rails in order to kind of get an idea of upgrade paths and things like that. So but having multiple Docker versions isn't necessarily a problem. As long as you keep them all up to date.